For the do now, 2 questions here. So number 1 is a math question. Number 2 is just conceptual, asking about a common ion. So for number 1, it says saturated magnesium hydroxide is in a solution with a pH of 10.17. What is the KSP? And then I gave a hint. So before we worry about the hint or even worry about calculating, when something says saturated, that means that the solid is at equilibrium with its ions. So saturated magnesium hydroxide, we start by writing the equilibrium equation, is MgOH2 solid at equilibrium with Mg2 plus 2 OH minus. So we would call this the dissolution of the solid. The solid is dissolving, or as much as possible is dissolving in pure water or distilled water. Right? So there's no ions or anything. We just have the solid at equilibrium with its ions. So then if it's asking what is the KSP, let's write the KSP expression. You have Mg2 plus times OH minus squared. So if we're solving for KSP like the question is asking, we should have numbers to plug in for Mg2 plus and OH minus. So let's set up our ice table. Doesn't matter how much solid we have initially or at equilibrium. Because this says saturated magnesium hydroxide is in a solution, we're going to assume we have 0 ions initially. I'm going to fill in this ice table with just our S's and then go back and figure out values. So if the solid dissolves, so then this is plus S, this is plus 2S. So then at equilibrium, here's what we have. Now, because I'm solving for KSP, that means that I should know my values for Mg2 plus and OH minus. They gave us a pH. They gave us a pH of 10.17. Well, from pH, we could figure out pOH, and then we could actually figure out OH minus at equilibrium. So if the pH is 10.17, then the pOH is 3.83, and OH minus is 10 to the negative 3.83. Because remember, OH minus is 10 to the negative pOH. So this 2S, OH minus, this 2S is 1.48 times 10 to the negative 4th. That's OH minus, so that represents 2S. This is where that hint comes in. It says use STOIC to determine the concentration of Mg2 plus. Well, if this is 2S, how would I figure out what S is? Divided by 2. So 7.40 times 10 to the negative 5th. Because we're solving for KSP, that is our only variable. We should have numbers that get plugged into Mg2 plus and OH minus. So we're using the pH to figure out OH minus. OH minus is twice as much as Mg2 plus. So now that gets plugged into the KSP expression. So 7.4 times 10 to the negative 5th times 1.48 times 10 to the negative 4th, and don't forget to square that. Squared times. So for KSP, I got 1.62 times 10 to the negative 12. 1.62 times 10 to the negative 12. Remember that K, any equilibrium constant, does not have units, just a number. A low KSP means there's not very many ions, so the solid doesn't dissolve very much. And then number 2, what happens to the solubility of a salt when a common ion is added? So if we add, let's just use up here as an example. If I add Mg2 plus, so this is at equilibrium, I add Mg2 plus, what's going to happen? It's going to shift left. Because if we have too many ions, it's going to shift back to the reactants. So that means it's going to shift back to make more solid. So if we're thinking about solubility, it becomes less soluble as a common ion is added. Less soluble means there's more solid and less ions. So more solid and less ions. So the more and more and more common ion that you add, the less and less soluble the salt becomes. Any questions on the do now? So if not, we're going to actually go through examples 13 and 14, which are going to be a really good way for us to review, kind of bring all of KSP together, especially example 13, kind of touches on each of the different things that we talked about with KSP. And then after we go through those two examples, you're just going to have time to work on mastering. So you'll have some time to be able to go through, work on mastering. So you can get out your notes. So get out your notes, the part 2 notes, which covers KSP and molar solubility. And we're going to go through example 13. Like yesterday, we'll go through some of it together. I'll ask you guys to solve, just so you can practice putting it in your calculator. So you make sure you can do cubed roots, things like that. So example 13 is actually broken up into 3 parts. So part 1 says a saturated solution of tin 2-hydroxide. I'm going to just stop there. I'm going to underline saturated solution, because saturated solution means equilibrium. A saturated solution means a solid is at equilibrium with its ions. So a saturated solution of tin 2-hydroxide has a hydroxide ion concentration of 2.2 times 10 to the negative 9th molar. Calculate the KSP. So this is similar to what we just looked at in the do now, where they're giving us concentration and they're asking us for KSP. So let's start just like we did before with writing the equilibrium equation. So we're writing the equilibrium for the dissolution or the dissociation of the solid in water. So if I were to put tin 2-hydroxide into water, it will break apart into SN2 plus and 2OH minus, but because we would classify this as an insoluble solid and it has a KSP, it's at equilibrium. And then the KSP expression that goes along with this will be tin 2 plus times OH minus squared. Again, we do not include tin 2-hydroxide because it's a solid. Any capital K, any equilibrium constant expression, no matter what your subscript is, this could be A, B, C, P, SP, W, you never include solids or liquids. So if we think about our ice table, again, I'm going to fill it in like I did before. I have no solid, and I have nothing else initially. This hydroxide ion concentration is at equilibrium. And if you say, well, how do I know that that's at equilibrium? Well, if you're calculating KSP, you have to have values here. If you're calculating KSP, you have to have values here. So we're assuming that we start with 0 of each. A certain amount of solid dissolves, and we get a certain amount of ions. Again, I'm doing this just so we can review the stoichiometry that's involved. Doesn't matter how much solid we have at the end. So I have S and 2S. Now the question gives us OH minus at equilibrium. In mastering, there are some questions that give you the ion concentration, and you're calculating KSP. So they tell us the OH minus concentration is 2.2 times 10 to the negative 9th molar. So 2S equals 2.2 times 10 to the negative 9th. Well, how do we figure out what SN2 plus is? Divide by 2. Because if this is 2S, SN2 plus is just S. It's 1.1 times 10 to the negative 9th. Here are your equilibrium amounts. Now you have what needs to go into the KSP expression. If you plug this in, don't forget to square. We can find our KSP value. I suppose using two significant figures because they gave us 2. 5.4 times 10 to the negative 27. So a very, very small KSP. It means that this doesn't dissolve very much. So notice they gave us this table that has chromium 3 hydroxide and tin 2 hydroxide. Well, now we know what the KSP is here, because we just solved. So number 1 was just having us solve for KSP if they give us one of the ion concentrations. Number 2 asks what a saturated solution. So again, saturated means that the solid is at equilibrium. So would a saturated solution of chromium 3 hydroxide have a higher or lower concentration of hydroxide ion than tin 2 hydroxide? Justify your answer. So now our focus is on chromium 3 hydroxide. A justification does not have to be words. A justification can be calculations. So what I would suggest doing is actually calculate OH minus. Calculate what the OH minus concentration would be. We cannot just compare KSP. We cannot compare KSP here because the ratios are not the same. Because this is 1 to 3 and 1 to 2. If the ratios were the same, we could just compare KSP. But since they're not, let's just go through and calculate the OH minus concentration. So we have 0 for our ions, plus S, and plus 3S for Cr3 plus and OH minus. They gave us the KSP. Make sure you're using the information that they give you. They give us KSP so we can solve for solubility. If we solve for solubility, we can in turn figure out what OH minus is. So I'll start by writing the KSP expression. Cr3 plus times OH minus cubed. So see if you can plug in the KSP for chromium 3 hydroxide and all of the variables and solve for S. I'll work through it up here while you're working through it as well. 3 cubed, remember, is not 9. This is where you want to make sure you can plug this into your calculator. So I got to this point. The quantity 3s cubed is 27s cubed. You multiply by the s, you get 27s to the 4th. So I divided by 27, and this is what I'm left with right now. in a graphing calculator or in a calculator that looks like mine. Either way, you have to put in the fourth root. So there isn't just a button in your calculator that is actually for root. Instead, in your calculator, what you want to do is you want to press 4, and then on a graphing calculator, I can hit math 5. And it looks like this after I hit math 5. On a calculator that looks like mine, you will actually hit 4, and then you'll hit second and the caret button, and that is X root. And then that actually will make it look like this, which is the same thing. So you just want to make sure that you can put in a fourth root. So I got S equal to 1.24 times 10 to the negative 8. Solubility is moles per liter or molar. Now, if you round it a little bit differently, that's fine. Mine was 1.235 because I just did 2.33 e negative 32. Now that's S. We are solving for hydroxide. Hydroxide is 3S. So make sure you multiply by 3. The goal here is to figure out how the hydroxide ion concentrations compare. 3.71 times 10 to the negative 8. So here's my hydroxide concentration for chromium hydroxide. And the question is, would chromium hydroxide have a higher or lower concentration than what we had up in number 1? Well, we're comparing negative 8 to negative 9. Negative 8 is greater than negative 9. So here I'll just say greater than. And to justify your answer, this all counts as a justification. A calculation counts as a justification. And then part 3, solutions of chromium 3 nitrate and potassium hydroxide are mixed. The final molarity of chromium 3 nitrate is 1.1 times 10 to the negative 8. And the final molarity of potassium hydroxide is 9.5 times 10 to the negative 9. Will a precipitate form? So I see the word precipitate. That immediately tells me Q versus K. That immediately tells me Q versus K. Now, this we have to think a little bit because they gave us 2 KSP values here. I'll think about if you had chromium 3 nitrate and potassium hydroxide, think about which of these two would be a product. Right? There's no tin in here anywhere. So the product that we would be looking for is the chromium 3 hydroxide. That's the KSP that we're working with. So will a precipitate form? We're comparing Q versus K. So I'm going to write my QSP expression. We're focusing on chromium 3 hydroxide. Here was our KSP in number 2. I'm not going to rewrite this whole equation because we rewrote it from number 2. But that's what our focus is. So our QSP expression is Cr3 plus times the concentration of OH minus cubed. Notice how it says the final molarity. If you remember yesterday, it was giving us the initial molarities that were being mixed together. So since we were adding volume to volume, we had to do dilution. Here they're telling us, here's the molarity, here's the molarity. Well, here, this 1.1 times 10 to the negative 8, there's our Cr3 plus. That's coming into the container. 9.5 times 10 to the negative 9th. There's our OH that's going into the container. You are just taking the concentrations that they give you and plugging it right into the QSP expression. There is no ice table because these are two different concentrations that we're putting into the container. So you're just taking those concentrations and putting them into the QSP expression. So I'll come over here. So Cr3 plus 1.1 times 10 to the negative 8. OH minus 9.5 times 10 to the negative 9, but don't forget to cube that. You have to cube it because that's part of the expression. I don't worry about multiplying OH or multiplying Cr or anything like that because for Q, we take the concentrations and we put it into the expression. So now we can solve. So I'm going to make sure I cube 9.5 e negative 9, multiply by 1.1 e negative 8. So QSP is 9.43 times 10 to the negative 33rd. Compare it to K up here. How does Q compare to K? It's less than. So that actually means there aren't enough ions. In order for a precipitate to form, Q has to be greater than K. So will a precipitate form? No. And then here's my justification because Q is less than K. So that means if Q is less, we don't have enough ions in here. We would need more ions to expect a precipitate to form. So that kind of ties in all of the different things that we've looked at with KSP. Precipitation, KSP, solubility. And so the last example is example 14. Just one question, but more of a conceptual question. So example 14 says, will the mass of zinc hydroxide increase or decrease if a small amount of soluble potassium hydroxide is added to a saturated solution? Justify your answer using the reaction quotient Q. So it wants us in our justification to include Q. So that means you're thinking about the K expression, but you're plugging in values for Q because if you're making changes to equilibrium, remember now that's Q. So take a minute, read through this, see if you can start to think about how you would answer this. This doesn't require a calculation. They don't give you a K. So this is more of a conceptual question. When it says soluble potassium hydroxide, that's KOH. It's soluble because potassium is one of the ions that is always 100% soluble, so it breaks apart. So that means that to this equilibrium, we're adding K plus and OH minus. There's no K plus in here anywhere, so we don't worry about that. But there is OH minus. So we're adding OH minus. So this was at equilibrium. Then we add OH minus to it. Well, let's think about what that would do to Q. If Q is Zn2 plus times OH minus squared. This was at equilibrium, so Q equaled K. Well, if I'm increasing the amount of OH minus, what am I doing to Q? Increasing it. So when I add OH minus, I'm going to leave some space over here to actually answer the question. But I'm going to say when adding OH minus, Q will increase And I'll say to be greater than K. Because if we're talking about Q, we probably want to compare it to K. So Q will increase to be greater than K. So then I'll say since Q, and I'll be more specific and say QSP is greater than KSP. Well, now Q is too large. So more reactant will be formed. So since Q is greater than K, reaction will proceed to create more reactant. So there's my justification. Now let's think about what that means. If it's creating more reactant, it's creating more of this solid. That's the zinc hydroxide. So if we're creating more solid, what's going to happen to the mass? It's going to increase. So here I'll say mass will increase. So I like leaving some space at the beginning to answer the question, and then we're just justifying our answer. So this is just a common ion question. This is why solubility decreases, because you're creating more solid. That means you're using up your ions to create more of the solid. So that's example 14. Any questions on this one?